So we are finishing up 3.5, the word problem that we missed. And then we will do 3.6. Reynolds Metal Company manufactures aluminum cans in the shape of a cylinder with a capacity, so that would be the volume, of 500 cubic centimeters. The top and the bottom of the can are made of a special aluminum alloy that costs 0.05 cents per square centimeter. So not 5 cents, but 0.05 cents per square centimeter. The sides of the can are made of a material that costs 0.02 cents per square centimeter. Express the cost of the material for the can as a function of the radius for the can. Okay, so if you think about the net of the can, we think about a can, and we're just assuming that it doesn't do what the cans do. They have like the concave part on the inside, right? We have a rectangle would be the outer portion of the can, and then the top and the bottom would be our cylinder, or I'm sorry, our circles. The area of a circle here is pi r squared. Does everybody agree with that? So the area of a rectangle is length times width, or length times height, or however you want to look at it. So I'm going to look at that as the height because I'm talking about the height of the can. But to find this, because I'm talking about in terms of the radius, to find my length here in terms of the radius, I can look at that as, well, that's the circumference of this circle, right? The formula for circumference of the circle is 2 pi r. So now my area of the rectangle is going to be my height times 2 pi r, or 2 pi r h. So I want the cost of the material for the can. So that's going to be the surface area. So I'm finding the area of each of these things and adding it all together, each of my faces. So my area of my outside piece is my 2 pi r h. And I'm multiplying that with the sides of the can, 0.2 cents per square centimeter. So that's going to cost me 0.02 times whatever my area is. Plus, my top and bottom, I have 2 of these circles. So I have 2 pi r squared, because they're going to be the same circles. And then the cost for the top and the bottom is at 0.05 cents. When I simplify those things, I have 2 times 0.02, which is 0.04 pi r h, plus 2 times 0.05, which is 0.1 pi r squared. So this would be the cost of the surface area. Cost in terms of my radius. But now we're talking about the capacity, the actual volume that it can have. So my volume can be 500 cubic centimeters, so centimeters cubed. The formula for volume of a cylinder is pi r squared h. So if I want this in terms of r, I just have to get rid of this h. So using this volume, I can solve this for h and plug that in, and it would make it in terms of r. So I have 500 equals pi r squared h. Just getting h by itself, I'm just dividing by pi r squared. So I get h equals 500 over pi r squared. And then this is just going to go in for h. So I have 0.04 pi r times 500 over pi r squared plus 0.1 pi r squared. And I'm just simplifying this. When you multiply fractions, you multiply straight across. So I have 0.04 times 500, which is 20 pi r on top, over pi r squared on the bottom. And then I'm just simplifying this fraction. My pi's cancel. R divided by R squared is just 1 over R. So I have a 1 R left on the denominator. So I have 20 over R plus 0.1 pi R squared. My last step is just to get a common denominator. So my common denominator here is going to be R. So I'm going to multiply this one by R over R. So I have 20 plus 0.1 pi R cubed over R. And that is my cost in terms of the radius of the can. That's all we care about is the radius of the can. Then we're going to graph it. So you can graph it on Desmos or on your calculator. 20 plus 0.01 pi x cubed divided by x. I'm talking about the cost, so I don't really care about the left-hand side here. I just it wants to know the value of the radius that will result in the least cost. So that's my minimum value. So my minimum value, you'd be able to see this pretty easily on Desmos. I'm going to have to do second trace option 3. Following my y-intercept here, so left. And then I'm kind of watching my y values to see when it starts going back up. So my minimum there, my radius should be 6.8. About 3 points. Y'all get that? 6.8. And then my least cost there would be the y value, and that's going to be 4.39, and this was in cents. We were in the 0.02, 0.05 cents, and that's going to be cents for the can. All right. Mm-hmm. Right here. Yeah. So I just from here to here. Is that what you're saying? Yeah. Okay. So I just simplified. My pi's cancel, and then I'm simplifying here. This is like having R over R times R. So one of my R's goes away when you just simplify. So then you're just left with the 1 R. Good question. Divide like bases, subtract the exponents. Any other questions on this one? Yep. Then we're going to look at chapter 3.6, polynomial and rational inequalities. Good. Polynomial and rational inequalities. So the steps for solving these algebraically. So you're going to write the expression where the expression's on the left and zeros on the right. So you're always going to move it over and have it greater than or equal to, less than or equal to, whatever it is, and then 0 on the right-hand side. Then you're going to determine the zeros. So where is the equal 0? Where are your x-intercepts? And then those are going to be your important points here. So I'm going to start by that. I'm just going to kind of go through here. I'm going to subtract 4x and 12 from both sides so that I can set it equal to 0 on one side. I have x squared minus 4x plus minus 12 is less than or equal to 0. To find my x-intercepts for this, you can either graph it, or you can use a quadratic formula, or you can factor it. Most of these are going to be factorable. So here I'm going to factor. My factors of 12 are 1 and 12, 2 and 6, 3 and 4. I need the pair of factors that add or subtract to give me b. So to get negative 4, I'll have positive 2 and negative 6. So I have x plus 2 and x minus 6 is less than or equal to 0. So then I'm going to use the zero product property to find my points here that are important, my directional changes, my positive and negative changes, my x-intercepts. So I have x plus 2 equals 0 and x minus 6 equals 0. I get my x-intercepts to be -2 and +6. Now that's not going to be your answer because you're not looking for where it's equal to 0, you're looking for where it's less than or equal to 0. So we want to know where it's negative or 0. So to find that, I'm going to use a number line. And I'm going to put my zeros or my points here on the number line in order. You don't have to like straight up do the number line. I just always put whatever my points are. -2 is less than 6. And what I have to do is I have to test points on either side of each of those values. If you think about an equation, when it goes through the x-axis, which are these points, it's going to be either above or below the x-axis to the left or right of those things. So that's what we're looking for, is where it's below the x-axis, where it's negative. So I'm going to plug in any value that is less than -2 because there's not a restriction over here. So I just picked the nearest one. Then I'm going to test any value in between -2 and 6. When I can, I like to test 0 because it's easy. And then I'm going to test a value that's bigger than 6. I'm going to test 7. And what I'm doing is I'm just plugging those values in to my equation here to see if it's positive or negative. I don't really care the value. I just need to know if it's above or below. So I have -3 squared minus 4 times -3 minus 12. That is +9. So it's positive here. It's going to be above the x-axis in that interval. If I plug in 0 here, I'm just left with my y-intercept, which is going to be -12. So this is equal to +9. This is equal to -12. And then I'll do the same thing with 7. And you get +9 again. So now, because it's less than or equal to 0, we want to know where the function is negative or 0. So it's going to be the interval over which the function is negative or 0. So because it's or equal to, I'm going to have filled in circles here where it is 0. And because we want to know where it's less than 0, this is our interval or our solution point. So we can write this in set notation or in interval notation. I'm good with either. In set notation, it's x such that -2 is less than or equal to x is less than or equal to 6. Interval notation is just -2 to 6 with hard brackets because it is inclusive. Questions on, and you don't have to do both of these, just one of them is fine. Questions on that? The next one, I need to get it to say equals 0. So I am moving that x to the other side. I have x to the 4th minus x is greater than 0. This one I can take a GCF out. So I have x, and then I'm left with x cubed minus 1 is greater than 0. So when I set each of those equal to 0, all I care about are the real solutions, so I don't have to factor that further. I get x equals 0. And when I solve that piece, because I've got x cubed minus 1 equals 0. Add your 1, take the cube root, you get x equals 0 and 1. Zero and 1 will be what goes on your number line. And I need test values that surround 0 and 1. So to the left, I'm just going to plug in -1. In between 0 and 1, I'm just going to plug in 1/2. And greater than 1, I'm just going to plug in 2. And I'm plugging it into my equation there where it says greater than 0. So I have negative 1 to the 4th minus negative 1 gives me 2. So that's positive. If I have 1/2, I get negative 0.4375. So negative 0.4, which is negative. And then if I plug in 2, I get 14, which is positive. Because here we're looking at greater than, we want to know where the function is positive. Because it's not or equal to, we don't care about where it's 0. We just want to know where it's greater than 0. So it's 0 at 0, so that's going to be an open circle. And shade to the left because that's where it's positive. Open circle at 1 and shade to the right because that's where it's positive. In interval notation, that's from negative infinity to 0, union or and 1 to infinity. In set notation, it's x such that x is less than 0 or x is greater than 1. Either way you want to write it, it's fine with me. You can just pick one. We're going to look at one rational inequality. With the rational inequalities, you're looking at where it's 0, your x-intercept, so that's where your numerator equals 0, and you're also looking at where you have vertical asymptotes or where it's undefined. Those will be important points as well. All right, so here, I need to set it equal to 0, so I'm going to subtract 3 from both sides. I have 4x plus 5 over x plus 2, and then minus 3. Greater than or equal to 0. I need to get a common denominator. So I'm going to multiply my negative 3 over 1 by x plus 2 over x plus 2. So I have 4x plus 5 over x plus 2. Minus, I'm distributing there my minus 3x minus 2, and this is all going to be over the same thing. Minus, not minus 2, minus 6, sorry. Minus 3x minus 6 over my x plus 2. Make that look better. Simplify my numerator by combining my like terms. 4x minus 3x is x. 5 minus 6 is negative 1. And I want to know where this x minus 1 over x plus 2 is greater than or equal to 0. So I need to know where it equals 0 and where it is undefined, where we have a vertical asymptote. So your function is 0, where your numerator equals 0, or at x equals 1. And it's undefined where your denominator equals 0, where you have a vertical asymptote, or if there's a hole. So we have x plus 2 equals 0, or x equals negative 2. So these are the 2 points that we're going to test. Because we're talking about greater than or equal to 0, which one is 0 and which one is undefined will matter here in just a second. So on my number line, I have 0 or I have 1, and I have negative 2. Let me switch those. Negative 2 and 1. On the left, I'm going to test f of negative 3. In the middle, I'm going to test f of 0. And on the right, I'm going to test f of 2. So I'm plugging it into my simplified form here. So I have negative 3 minus 1 divided by negative 3 plus 2. And I get a positive 4. So it's positive there. At 0, when I plug in 0 for x, I'll get negative 1/2, which will be negative. And then at 2, I'll get 1/4. Which is positive. We want to know where it's greater than or equal to 0. So it's greater than 0 in the positive places. It's equal to 0 at x equals 1. So that's going to be a filled in circle. But it's not equal to 0 at -2. It's undefined. So that's going to be an open circle at -2 because that is where your function does not exist. So my set notation would be x such that x is less than -2 or x is greater than or equal to 1. My interval notation would be from -∞ to -2 union 1 inclusive to infinity. We are going to look at number 4 on Desmos. We're going to have to create an equation for it. All right, so we're looking at Desmos. Let me adjust. Y'all can see. Okay. So this one, Tammy is considering leaving her $30,000 a year job and buying a cookie company. According to the financial records of the firm, the relationship between pounds of cookies and profit is exhibited by the table below. Draw a scatter plot of the data. So I'm going to start by drawing that plot. So to do that, I'm going to go to the plus on Desmos and the table. And then I'm going to type in my X values or my pounds of cookies in X1 and my Y values or my profit in X2. So if I have 0, okay. So now it says to draw the scatter plot. So I'm going to adjust my window here. My X's are going up to 700, so I'm just going to look at it up to 1,000. My Y's are going from -20,000, and the highest is about 50,000. So I'm going to type in 55,000. Whoopsies. For my highest and my lowest, I'm going to have it at -25,000, just so I can see all my points. Oh, shoot. Too many zeros. Sorry. Okay. So there is my scatter plot. It says to find the quadratic function of best fit. So to find my quadratic function of best fit, I'm hitting y sub 1 tilde. Then I'm going to write out my quadratic equation. A x sub 1 squared plus b x sub 1 plus c. So my equation there would be y equals -0.31 x squared plus 295.86 x minus 20,042.5. I'm going to type that in here so we can see that, what it is. All right, so there's a little bit of a rounding error, so you can see how that's slightly different than the one that's on our graph here. It says to find the zeros on the calculator, or you can use the quadratic formula. So to find the zeros on the calculator, you won't need to actually type this into Desmos. So I'm going to find the exact ones here. I have a 0 at 73.426 and a 0 at 875.285. So if you were doing the number line, those would be the numbers that go on your number line. You would test to the left, in the middle, and to the right of that. Because you have the picture of the graph right here, you don't have to test. But we want to know where this is positive. So it says, use the function to determine the number of pounds of cookies that Tammy must sell in order for the profits to exceed $30,000 a year. So what we're writing on our paper, and I'm just going to type it right here so you can see it, is we want to know where this equation, negative 0.31x squared plus 295.86x minus 20,042.5 is greater than or equal to, does it say or equal to? It exceeds. So no, so just greater than 30,000. We want to know when it is better for her to do this than to keep doing the job she's doing. So that's the equation you would write on your paper. To get that equation on your graph, you are going to subtract your 30,000 from both sides. So you can just straight up say minus 30,000. And then this is the equation we're looking at. So to know how many pounds of cookies she would have to make it worthwhile to quit her job, 219.732 and 734.655 would be your two numbers for your number line. You want to know where it is greater than or equal to 0 there. No, not great. Well, or equal to, sorry, just greater than. It would be greater than 0 in between these two because that's actually greater than 0 on our graph. You don't actually have to test it out. You can look at your graph, and your answer for that would be between, and I'm going to say about 220 and 735. So I would write that answer in interval notation like this. That's just interval notation. I don't actually need the point. I'm just showing you without having to go back and forth on my screen here. So that would be your answer for part C. And then part D, it says determine the number of pounds of cookies she should sell in order to maximize her profits. So I'm looking at the maximum here. She needs to sell about 477 pounds of cookies. And then that maximum profit would be the Y value there. But remember, we have to add that 30,000. So 20,548.74 would be her profit in excess of 30,000. So plus that 30,000, her maximum profit would be $50,548.74 roughly. 548.74 would be her maximum profit. Questions? Bottom line is you can solve all of these using the graph and knowing what less than, greater than, equal to, all those things are 0. And then the rational functions, you have to also look at your vertical asymptotes or holes and things to the left and right of that.